All right, so here is the orbital notation on the top for calcium. Here's the electron configuration for calcium. Now we said when we were talking about chlorine earlier that chlorine wants to fill up its outer energy level by adding an extra electron. Okay? Well, I could fill up the outer energy level of calcium by adding a 4p sublevel and putting in 1, 2, 3 orbitals, and I could do all that. But that'd be adding 6 electrons. That's a lot of electrons to add. Okay? What calcium actually does is to get rid of all of these electrons. Get rid of the 2 outermost electrons. And so what we have left now is a full outer level. Huh? That's what it tends to do. If it's going to form an ion, and it often does, more often than not, you're going to find it in ionic form. In fact, it's very rare you don't find it in ionic form. You have to make it. Then calcium will exist without those outer 2 electrons. Okay? Well, if I get rid of 2 electrons, what's this going to be? It's not a calcium atom anymore. It's an ion. And what charge is that ion going to have? All ions have charges. Well, let's see. Calcium had 20 protons, but now it doesn't have 20 electrons. It has how many electrons? 18. 2, 4, 6, 8, 10, 12, 14, 16, 18 electrons. So protons are positive, electrons are negative. What charge does this calcium ion have? 2 positive. Okay? 20 protons, 18 electrons, that's a 2 plus charge. What? Yes, you got it. There you go. Alright, so if I'm going to do the electron configuration for a calcium ion, I get rid of those 2 electrons. And I put my 2 plus charge over here. And so now this, as a result, actually without the 4s on there, because the 4s is now gone. Okay? Let me point out 4s over here. Yes, you have to have 2 plus. It has to be 2 plus, not just 2, 2 plus. Yeah. What? How was it 4s? Okay, well, calcium is in the 4th row, and that represents putting electrons into the 4th primary energy level. And this is the S sublevel region over here. Count down. I guess, yeah. Row 1, 2, 3, 4. Yeah, if you mean that. Okay. All right. So then this is the orbital notation. Oh, NO, not NAT, but notation for the ion of calcium. Now, remember when we added electrons to stuff, we changed the ending to IDE. We don't change the ending to anything when we have a positive ion. Okay, so this is just a calcium ion. Okay? And so this then is the electron configuration. You know, it's kind of like traditionally women change their name when they get married. Men don't. So negative ions change their name and positive ions don't. No, good. What? What? Oh, sorry. When you add electrons to an atom,
You're saying women are negative.
I did not say women are negative. I did not say that. Boy, that is extending the Meaning way, that's stretching it past the breaking point here. All right. There are men and women that are negative, and men and women that are positive. Come on. Huh? I'm negative? I'm positive? Okay. Well, I'm positive that this is the way you write a calcium ion. Okay. Huh? Negatively funny? Okay. All right. So, now listen. I can also write this using noble gas configuration, or noble gas electron configurations. Okay. So calcium, 2 plus. What's the next lowest noble gas? Argon. Well, guess what? That is the configuration for argon. Huh? Yeah. Guys, pay attention. This is important. If you're not listening, you won't know. That is the configuration for argon. So calcium's noble gas, the calcium ion's noble gas configuration is that. Yeah. What's the element number? Oh, 62? We're talking about 62? Oh, let's see here. Noble gas for that. SM, colon, brackets, RN, in brackets. It would be 7S2, 6D1, 5F5. Actually, I'm sorry. I got to switch. You got to switch the D and F. I mean P and F. So it would be 5F5 before the 6P1. But it's on that reference I gave you. And yeah, and we won't get into why you have to switch those around yet. Because if samarium is the element we're trying to write an electron configuration for, we count our way back until we hit a noble gas. 62, 61, 60, 59, 58, 57. I'm sorry, it's xenon, isn't it? Oh man, help me. Xenon. Okay? Not radon, but xenon. I'm trying to do it all in my head. I didn't realize I should have written it on paper. Yep.
How do you know if you have a number over here?
Just count your way back. Follow the numbers. Follow the yellow brick road. You don't want to follow the yellow brick road? Oh, sorry. Okay. Alrighty, let's talk about scandium. Scandalous scandium. Alright, you should be writing and not talking. If you can't write and talk at the same time, you should not be talking. Okay, I want you to do what I've done and write this much and stop there because I want to talk about what happens next. Okay? I want you to write what I've written and stop because I want to talk about what happens next. Scandium. Yeah, as far as I know, it's scandium. I wish I'd kept my chart. The one with 1S, 2S, 3S vertically. You got yours? That one right there. Can I borrow yours a minute? Yep.
We have the same number.
Okay.
Oh, that's okay?
Yeah. All right. Remember this chart we made? Okay. So we filled up 1S, and we start on the next arrow. We get 2s. The next arrow we got to 2p and then 3s. The next arrow we got to, let's see, 3s. And 3p was right here. Then 4s. On the next arrow we come to, what is that? What is this right here? 3d. Alright. Listen please. When we get to the D sublevel region, that's the transition metal elements region, right in here, you have to drop back a primary level number. We're not filling up 4 when we're in the transition metals. We're filling up 4 here and over here, but in here we're filling up 3. Okay? So instead of going to 4D, we're going to 3D. And there are 5 orbitals in a D sublevel. Okay? Even though there's only 1 electron there, we're still got to have all 5 orbitals. Okay? Thank you for letting me use that. Okay? Now, that's the orbital notation. When you get into the transition metal section, some strange things happen about the oxidation numbers, and that's the numbers you get when you take off or add electrons. Okay? So I want you to flip back to the periodic table that has oxidation numbers. Periodic table with oxidation numbers. Now scandium has a 3+ charge. Okay? So what seems the most reasonable way to get scandium to a 3+ charge? Take away those 3 right there we just put in there, didn't we? Okay? And so scandium now has a 3+ charge, and it's not the scandium atom anymore. Scandium ion with a 3+ charge. Got that? Okay, so the electron configuration for scandium, the atom, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d1. But the ion of scandium, 3+, 1s2, 2s2, 2p6, 3s2, 3p6, or scandium, 3+. What's the next lowest noble gas? Argon. 1s2, 2s, I'm sorry, that's not right, 3s2, and 3p6. Oh, actually, you know what? That's it right there, because argon's orbital notation is this orbital notation, or electron configuration. So we're done for that one. If I compare it to the argon's electron configuration, it's the same as this.
What? If you took those 3 out, how come you left them on the
This is the atom, this is the ion.
No.
Oh, here?
If you took those out, why did you leave them on there?
Well, I was just showing you the difference between the atom, which had the electrons up here, and the ion, which doesn't. Okay? Trying to show you what happens to get the ion. Okay? Alright. Let's go to germanium. So write the orbital notation and electron configuration for germanium.